Are you sick and tired of having to press the same button over and over again countless times? If so, you're in luck, because today I'm going to be teaching you how to make your very own button mashing machine to prevent your fingers from cramping up. But before we get started, warning, I am not an engineer, and I don't really know what I'm doing, so only follow along if you have professional supervision. Viewer discretion is advised. Alright, so this is what the model of the machine is going to look like once it is finished. Here are all the items that you're going to need. A 12-volt DC motor, a switch that has an on and off button, and a turning knob to adjust the speed, a power supply, a computer cable, red and black wires, and a wire cutter, alligator clips, 1/2 inch thick oak wood and 1 to 2 inch thick basswood, a thin cylindrical piece of wood, an extremely thin but also strong piece of sheet metal, wood screws of various sizes, small mechanical screws, numbers 10 and 4, small washers, number 4S, a 1/2 inch metal socket, Velcro adhesive, a normal sized screwdriver, a small sized screwdriver, wood carving knives, a box cutter, a table saw, a power drill, regular drill bits, cobalt drill bits, small C-clamps, a multimeter, a tape measurer, wood glue, and last but definitely not least, a pencil. Alright, now that we have all of our items, we can move on to the first step. The first step is going to be cutting the computer cable. Now, make sure that when you're cutting the computer cable, you cut it at the part that's supposed to go into the computer and not the part that's supposed to go in the outlet, because otherwise this cable will be useless and you'll have to buy another one. Alright, so there's 3 different types of wires here. We've got the black wire, the green wire, and the white wire. Now these are kind of important on their placement on where they're going to go into the power supply. As you can see on the power supply, we have L, which stands for live, N, which stands for neutral, and this little symbol here, which is ground. The black wire is going to go into the live port, the white wire is going to go into the neutral, and the green is going to go into the ground. The second step is to connect the 3 wires to the power supply. The live wire, the neutral wire, and the ground wire. Alright, now that everything's connected, let's plug it in. Alright, I plugged it in, and let's see, is it even plugged in? Ah, I can see a little green light. Let's see. Yeah, there it is. The little green light. Alright. So that looks good. Let's wait a few seconds to make sure there's no smoke or anything that comes out of here. Okay, I think it looks good. Alright, perfect. So the next step now is going to be plugging in the multimeter so that we can check the voltage and adjust accordingly. Alright, so now we're going to be using a multimeter. For any of you guys who have not used one before, don't worry, this is going to be my first time too, but honestly, they're really not that hard. I've seen some video tutorials online, and they're not that hard to figure out. So the first thing you're going to want to do is you're going to want to connect these 2 things that come with the multimeter into the holes, the respective holes. Now there's 3 holes, so you have to plug them into 2. First hole is going to be the red, which you're going to plug into this hole that has the V, upside down horseshoe, H and Z above it, like so. There we go. And the next hole that you're going to need to fill is going to be with this this black thing here, and it's going to be the hole that has the COM above it. All right. So the other thing is you're going to want to put the red alligator clip into the power supply where it says V positive, and the black alligator clip in the power supply where it says V negative. What you're going to want to do is you're going to want to use the first symbol, which depending on what kind of multimeter you get, this might not be the first symbol on your multimeter, but the symbol that is the V with a straight line and then a line, broken down line underneath it. It almost looks like dots, but I think it's a broken line, which stands for direct current. Basically because the power supply is taking alternating current, which is the V with the squiggly, and it's transforming it into direct current. So alternating current is like outlets, direct current is like batteries. But this power supply is specifically turning one type of current into another type of current. Make sure that anytime that you hook something into the power supply or take anything out, make sure that it is off, because otherwise you will get electrocuted. And it's happened before, and it was not a fun time. Okay, so now that we have these two clipped on where we need to, let's turn the power supply back on. Okay, and now let's turn the multimeter on to direct current, and let's see what we get. Okay, so this looks like it's the voltage that it's outputting is 23.9 volts. Oh, it keeps changing, 24, 24.1. It's roughly where we want it to be. For those of you who don't have it at 24 or close to 24, there's a little tiny yellowish screw here, and basically what you do is you take your screwdriver and you kind of adjust it. When you turn it into the clockwise direction, you're going to increase the voltage, and when you turn it into the counterclockwise, you're going to decrease the voltage. I'm going to leave mine as is because it's pretty close, and it'll definitely it'll do the trick. So now we're going to turn this off, and then we're going to unplug the power supply, and then I'm going to take some wire, red and black wire, and we're going to connect it to the power supply, and then on one side we're going to connect to the power supply, and on the other side we're going to connect it into the switch, and we'll see if it works. Alright, so the switch has some instructions, not really instructions, but it tells you exactly where you need to plug in which wires. It has power minus, power plus, motor minus. So same kind of thing. You want to make sure that plus is red and it says power because it needs the power. And then we have power minus, and we got some power minus going on over here as well. So which is the black wire. So we're going to plug these into the switch. The next step now, once you have the switch hooked up to the power supply, is you're going to want to hook up the motor, and it's going to go motor plus, motor minus. So you're going to connect two more wires. I'm going to cut more wires, and we're going to connect now the switch to the motor. Okay, so once you have the other red and black cables connected to the motor part of the switch, and then conversely connected to the alligator clips, what we're going to do is we're going to connect them to each side of these. Now there's a little red kind of marker labeled where the positive side is supposed to be, so we're going to connect that alligator clip to that part right now. Okay, and then the other side, of course, doesn't need to be colored in, because if one side's colored, then you already know what the other side is by process of elimination. So we're going to connect that to that. Okay, and so let's just make sure. Be careful here not to bend anything. So now the power supply is not plugged in, so I'm gonna plug in the power supply, and this thing is off, so I don't want it to just go all crazy. And let's plug this in and let's turn it on and see what happens. I'm gonna turn it on right now. There we go. It was on lowest setting, so you just gotta crank it up. There we go. Makes a little bit of a noise, but hey, it does the job. It works. It's awesome. It's a little slow, even in its maximum settings. But it gets the job done. A little loud, but it works. Okay, now in case we want to switch it to turn the opposite direction, right now it's turning into the clockwise direction. We're going to turn into the counterclockwise direction. Jumped a little bit, that was cool. Alright, awesome. That's awesome. So once we have the electrical part of the machine done, now we can focus on the construction part of the machine. When it comes to the construction part of the machine, I drew out the models in more detail, along with all the pieces that are needed and all of their sizes. I highly recommend that you do the same thing, because it will help you make more accurate measurements and know exactly where on the wood you have to cut. Okay, so before we start cutting our wood, we are going to want to make some markings just to make it easier for us so that we know exactly where we need to cut. And it would also be very helpful if you mark what each piece is so that you know exactly where each piece goes. Otherwise, you might get a little confused. So as you can see, I did this earlier with a ruler and a pencil just to make it easier. My controller is going to be a little bit different than yours. It really depends on what kind of controller you want to use. If you want to use a different controller than what I'm using, then you're probably going to want to make it a little bit different, but it gives you a better idea of exactly what you'll need to do. The next step is cutting the wood and the metal. Now, make sure that when you use your saw, whether it's table or otherwise, to always wear protection. And when I say protection, I mean gloves, goggles, and a mask that covers your nose and mouth. A friend of mine once inhaled metal shavings while working on a project because he wasn't wearing a mask, and he ended up in the hospital because the metal cut up his lungs and he had internal bleeding. He's fine now, but the moral of the story is that safety should always be your top priority. Now, there are 3 tiny pieces that each have their own unique shape, and since I'm not skilled enough to make those shapes with my saw, I decided to just carve them instead. You can do it however you like, but I personally think that carving them is the better option in order to be more precise. The first piece needs to look like a bow tie, the second piece needs to look like the letter U, and the last piece needs to look like an egg. The next step is carving the base wood into the 3 shapes that we need. Please make sure that you wear gloves, because remember, safety is always the top priority. Now, if you've never carved wood before, the only advice that I can give you is to just give it a try and take it slow. I actually bought a lot of base wood beforehand so that I can practice making a variety of shapes, and it helped. It's a little tricky at first, I'm not gonna lie, but you will definitely get the hang of it the more you do it, and it becomes kind of intuitive. Just make sure that you never carve against the grain, because you will start to tear the wood and take off more than you should. Start out by making a simple shape, and then once you feel comfortable with that, you can work your way up to other more complex shapes, and eventually you will be able to carve just about anything. Now, after carving for a couple of hours, I realized that carving wood is surprisingly relaxing. It will definitely help you take your mind off of the things that are stressing you out, and the best part is, once you are finished, you will end up with a lot of cool wood sculptures that you made. Alright, so once you cut your wood exactly how you want it, I would recommend for you to do a little bit of drawing on the wood so that you know exactly where all the pieces are going to go. And on the wood that you're going to be using, I also recommend for you to mark down exactly where you want the screws to be. Now, you're not going to want to use the same screw for everything because some screws need to be longer or shorter than others depending on how you're going to do it. So I would definitely write down exactly the type of screw you're going to be using and then use the corresponding drill bit based on that. The next step is drilling holes into all of the wood pieces and into the metal piece as well. Now, when it comes to drilling, you are going to want to be as perpendicular as possible so that all of your holes are nice and straight. Also, make sure that you have an extra piece of wood underneath everything that you drill into, because otherwise you will end up making a bunch of holes into your table, and people will make fun of you for the rest of your life, or at least until you get another table. Now, keep in mind that you are going to need to alternate between drill bits depending on which screws you decide to use. Just make sure you compare and contrast each bit to each screw beforehand so that all of the holes are the exact size they need to be. Now, metal is a bit trickier to drill into than wood, so I recommend that you use the C-clamps to keep the metal and wood together to prevent it from rotating with the drill. The next step is to screw all of the big pieces together along with screwing the motor to the metal piece. Now, I personally prefer to hand tighten each screw instead of just using a power drill because sometimes the drill will destroy the head of the screw and then it will be extremely difficult to put it in or to take it out of the wood. Now, if you do happen to find yourself in that situation, don't worry, because there are a few methods that I know of which are all very effective that you can use to take the screw out. For example, you can use a screw extractor, which is a special drill bit designed for this very purpose. You can also use vice grips or pliers, depending on how deep the screw is into the wood. Now, if neither of those methods work, then I suggest you get a small nut and glue it directly to the screw. Then, once the glue is dry, use a wrench on the nut and the screw will follow. If you do end up using this method, make sure the glue doesn't spread to the wood, otherwise the nut will be just as stuck as the screw is. So next, we're going to be assembling these little pieces together. So we have the first, which is going to be connecting the egg shape with the little bow tie / popsicle thing. Put the first washer. You're going to want to use 4 washers and 3 nuts. Alright, put it through. Then second washer in here. And then the third washer as well. Then you're going to want to attach this piece. Then you're going to want to attach the final washer. And then all 3 nuts, one after another. Alright, next we're going to be attaching the other side of this to the U-shaped, which has the little cylindrical piece of wood, which I glued inside. Made a little hole and I glued it. Nice and sturdy. You're going to need 1 screw, 1 nut, and 4 washers once again. So put the first washer through the screw. Just when you're about to see that it's about to pass through the hole, you put the second one. Then you put the other piece in, screw it in gently, and then as soon as you see that it's about to go out, it's about to go through, then you put the last one, the third washer. You gotta be very careful. Sometimes you need to use a little tool, small tool, to make sure that it gets exactly where you want it to be. And you can actually even use the tool, make it easier. Looks like it's good. Looks like it caught both of them, so that's nice. Alright, last but not least, got the final washer, put it through, and the final nut. Okay, make sure that it's nice and tight. Think it's going anywhere? Great. Gotta make sure not to break the wood because it needs to be very tight. The tighter the better. But then again, you don't want it too tight where it's not going to go through the hole. Looks good. I think it should clear. Doesn't look like it'll hit the screws, but let's just be on the safe side and let's not pass any of them. Okay. So the way that this is going to work, the motor is going to be pushing the egg, and the egg is going to be pushing the bow tie is going to be pushing the U is going to be pushing this, and then it's going to go through and it's going to push the button. But we're also going to need to put a block here to kind of hold everything together. When it comes to the wooden block piece, you're going to have to measure where you want the hole to be for the long cylindrical piece to go through. It all really depends on how deep you place the egg piece onto the motor. Now, you can either drill even more holes into the block and then into the metal piece as well, and then screw them both together, or you can use a magnet instead, and it will work just as well. You just have to make sure that the magnet is strong enough to be able to hold the weight of the block. Now, you can either glue the magnet directly onto the block, but if you do, you'll need to adjust where the hole for the cylindrical piece is going to be for that added distance from the metal piece. Or you can simply carve a hole into the block big enough to fit the entire magnet into it, and then glue them both together. Now that the wooden block is firmly attached to the metal piece, you need to move it closer to the tiny pieces so that it has enough leverage to keep all of them up. Okay, so once you have everything adjusted the way that you like it, now it's going to be time to attach it firmly to the wooden piece that you made that's specifically for this, and screw everything in. The next step is attaching the metal piece to the rest of the motor mount. Now, once again, I am using a screwdriver and not a power drill because I want to make sure the heads don't get destroyed. I've learned that lesson the hard way, and a screwdriver is definitely the way to go. Once you have everything nice and screwed in, this should be extremely sturdy and extremely tight. It shouldn't look like anything's flimsy or anything like that. Everything should be extremely bonded together, almost as if it was glued together, but it's screwed in together. Okay, so in order for the cylindrical piece to stay nice and straight as it moves back and forth, you're going to have to attach a little tiny weight at the end of it to counterbalance all of the weight of the tiny wood pieces and screws and nuts that the cylindrical piece is attached to. I used a 1/2-inch metal socket, but you can use anything else that you like. Just make sure that it fits nicely onto the cylindrical piece and that it won't be constantly moving back and forth as the cylindrical piece moves, and make sure that it is roughly 25 grams or so. Okay, so the next step is going to be connecting the motor mount to the controller mount to prevent the cylindrical piece from pushing the controller away. The best way to get this done is to use another piece of wood underneath the motor mount that's long enough so that you can adjust the motor mount exactly where you want it to be. Now, I used Velcro adhesive to connect these two pieces together. I really like the Velcro adhesive because it's very lightweight, but it's also extremely strong. And once they are Velcroed together, they're basically stuck together. But the one real advantage of Velcroing these pieces together over gluing them together or even screwing them together is that once you are done using the machine, you can disconnect the pieces so that it will be much easier to store them. The final step is going to be reconnecting the motor back into the power supply so that it has an electrical current once again. Now, before I turn this machine on, I want to mention one quick thing, and that is that my switch no longer works. I have no idea why. But when I plugged in the power supply into an outlet, I started noticing a strange burning smell that was coming off of the switch, and the red light that usually turns on wasn't turning on anymore, so I was worried that this thing would actually catch fire. So I disconnected it from everything and I just removed it from the equation entirely. And now the motor is connected directly into the power supply with the black and red wires. Now the motor has two terminals, the positive terminal and of course the negative terminal. Each of these terminals have a little tiny hole in them. So I just put the wires through the little tiny hole and then I twisted them so that they are now firmly in place. So now the only way to turn this thing on or off is to do it the good old-fashioned way and to either plug the power supply into an outlet or to plug it into an extension cord that's plugged into an outlet. Okay, here we go. Awesome. Oh my gosh, it actually works. Nice. I hope you guys enjoyed this video and will actually take the time to make your very own button mashing machines because they really will make your lives a lot easier. I had a lot of fun making this machine and I'm actually looking forward to making something else. So if you guys have any cool, fun, or even crazy ideas on what I should make next, let me know and I'll try to figure out how to make them. Alright, until next time guys, keep it easy.